Good afternoon. Can you hear me? I'm very pleased this afternoon to introduce James Patchett. James is founder and president of Conservation Design Forum, Incorporated, who's our fifth Emmons Lecturer for the year. I also would like to recognize and have him wave David Yaka, who is Director of Landscape Architecture and Planning, as well as Senior Partner of Conservation Design Forum. He and Jim will be spending the next 3 days in the college visiting with various classes and giving some individual reviews, discussions of students and individual team projects. I'd like to tell you just a little bit about Jim as he begins his talk. He's a member of the American Society of Landscape Architects and a LEED accredited professional. As I said, he's founder and president of Conservation Design Forum, Incorporated, which is a multidisciplinary consulting firm in Elmhurst, Illinois, dedicated to the principles of sustainable land planning, design, development, and long-term systems management. Jim combines his training as a landscape architect and as a hydrologist in the development of natural resource-based site planning and design techniques that involve the integration of innovative water resource management and ecological restoration strategies into built environments. Jim pursues solutions that integrate state-of-the-art green building and site infrastructural measures to restore ecological functions in both built and natural environments. Jim has directed the development of ecological strategies for many noted sustainable design initiatives, such as Sears Prairie Stone in Hoffman Estates, Illinois, Tell Labs corporate headquarters in Naperville, Coffee Creek Center in Chesterton, Indiana, and the Chicago City Hall Green Roof Project. In addition to his duties with Conservation Design Forum, Jim is also co-founder and president of the board of Conservation Research Institute, which is a nonprofit organization dedicated to furthering applied research and educational opportunities in sustainable planning, design, installation, restoration, and long-term management within built and natural environments. Jim is past chair of the American Society of Landscape Architects Water Conservation Professional Interest Group and a former collaborative faculty member at Iowa State University. He holds bachelor's and master's degrees in landscape architecture and master's degree in civil engineering, all from Iowa State University, and has completed all the coursework for his PhD in the University of Michigan's Natural Resources School. So without further ado, I would give you James Patchett, who is widely recognized as one of the leading people in the nation in the promotion of sustainable land planning and design. Jim? Jim's lecture is set for an hour and a half. If people have to leave to get to another class or something, at the end of the hour, he said that's okay, don't worry about it. But I'm saying thanks.
Thank you, John. Can everybody hear this all right? Now, I have a hard time standing in one place once I get going, but I'm trying to make sure that I'm within camera jiggle here, so just let me know if I start to wander outside of the camera. On behalf of my colleague David Yaka and I, it's a pleasure to be here today and share some time with faculty and students and others over the next couple of days. And I've got always more than I can shove into 90 minutes here, so I'm not going to waste any time. I'm going to take right off into this, and as John said, if any of you have to go, please feel free to take off whenever you need to. So without further ado, my program today is going to start out with a review of kind of historical ecosystems functions. It's going to be kind of Science 101 because if we don't understand the way the world works, wherever we live and work and play, we don't have much of a hope of designing sustainable solutions. And I would say much of our training, particularly in the design fields, historically has been more in the visual arts than it has deeply embedded in the understanding of ecological system functions. And when you get too far on to one side, not that you can't have great beauty, you should have great beauty, but that beauty has to be integrated into the underlying physical and cultural fabric of place. And that's what we're just starting to catch up on, I think, in the entire kind of sustainable design realm. I'm going to talk a fair amount about some of the liabilities associated with conventional planning and design practices, particularly water management practices, or I should say water mismanagement practices, because you'll see throughout the course of this program and over the next several days, while we'll talk about a broad scale of types of projects from very site-specific up to regional contexts, water is going to be the thread that ties all of this together for us. We're a quote-unquote water-centric design firm. Water is where we begin every design, and it leads us through every step of the way, because it's our philosophy that if we can learn as designers and as engineers, as construction practitioners, how to actually receive the life-giving precious resource of water as a resource and not generate a waste product to be sent off and dealt with someplace else and then leave ourselves in deficit, well, then that will lead us to quality design at every other step of the way. So water will be this underlying theme. And then I'm going to review some of the basic green infrastructure measures that we and a lot of other people like us have been working with, things that you're already designing in your coursework here, green roof technologies, modular and other kinds of porous pavement systems, rainwater harvesting and reuse. And then I'm going to go through a whole bunch of different case studies, and I'll do it fast and furiously. And we'll be around, like we said, for the next few days. So if you have questions, it's unlikely that I will have time within the context of 2:30 to be able to answer those today. But just come up, write down your questions, and we'll be glad to go through them with you. Well, if you want to begin at an understanding of how the world works, you have to begin at the beginning, or at least the Holocene age beginning, which is where you live here in Muncie, Indiana. We're part of the Wisconsin glaciation, just like we are in the Chicagoland area, and you can imagine for thousands of years, mile-high sheets of ice roaming back and forth over a very rugged subterranean landscape. If you've ever been up to southwestern Wisconsin or the very little tip up around Galena, Illinois, of northwestern Illinois, it's the driftless zone. Nobody knows why, but it's really the only area of the upper Midwest that's primarily non-glaciated. Well, that's the way most of the world around here worked, or how it looked. The landforms, bedrock, very much at the surface. But when this ice shield was moving back and forth, grinding down that bedrock limestone parent material underneath it, and then finally going back and forth and moving off to the north and leaving what we have here today, a much more contemporary, gently rolling till plain, and then our river systems mimicked those deep river corridor systems, but as the meltwaters came through these major sluiceways and depositing the silts and gravels, or the sands and gravels, and then the silts and the clays tended to get washed out across that plain. And so today we live up on top of a landform composed primarily of sands and silts and clays, glacial till. So it's a much more gently rolling landform than what would have been here prior to those glaciers. Well, as the glaciers retreat and finally go off to the north and carve out the Great Lakes and carve out our river systems and deposit our contemporary landforms, in come the plants, in come the animals, and very importantly for us, in come the human beings. Because for as long as there has been a post-glacial Indiana, human beings have lived here and have had a very profound influence on what we today refer to as nature. Indiana, and for that matter, anywhere across the face of North America, was a very lived-in landscape. And the human beings had very purposeful interactions with that landscape to the point where all of the flora and the fauna and other aspects evolved, co-evolved with humans, again, in very purposeful ways. So here's where I go back to kind of Science 101, photosynthesis. Of course, it's why we all exist. You have essentially sunlight energy in the presence of moisture coming up through the root systems, carbon dioxide from the atmosphere, and then of course those little green solar receptor cells in the living tissues of plants that through the combination of these processes coming together actually have the ability to convert sunlight energy into our life energy, actually. So you give off oxygen and energy. So photosynthesis is essentially a fairly complex but simple to kind of grasp combination of 6 molecules of water and 6 molecules of carbon dioxide, which produce 6 molecules of oxygen and a 1,6 carbon chain of sugar, which of course is our life. Every living organism on Earth has the inherent genetic ability to take that sugar and convert it into our own life's energy, the embedded energy of the sun. Without this, we would not exist. Well, why is that particularly relevant? Well, we live in a part of the world that is still part of this massive grassland system of the upper Midwest. Of course, a mosaic of our woodland systems, but still massive prairie ecology. And when a prairie ecology is photosynthesizing, as you can see from this image, if I could share one thing about the way the world works in the upper Midwest as it relates to these grassland systems and everything else, it would be this cross-section, because on average, anywhere from 70 to 90% of the total plant mass existed below ground in a massive, massive root architecture, somewhere to the tune, on average, of 15, 18 to 20,000 pounds of root mass per acre. Now today, in an acre of corn and soybeans, which is what's primarily covering most of the upper Midwest that isn't covered by a building, a parking lot, or a turf grass lawn, we're looking at somewhere around 300 to 600 pounds of root mass per acre in an annual plant that is spending most of its energy growing above ground and producing fruit, whereas this is a perennial system. So as this perennial system is photosynthesizing, you're actually, at the end of the year, usually within a couple of days of the first hard frost, the native people would fire that landscape off. In fact, the Algonquian word, the Algonquian-speaking people of this part of the world, their word for prairie is mashkota. It means the burned over bare land. So they would come in, fire that landscape off, and in so doing, they would release a portion of the carbon that had been fixed that year, but only the portion that had been fixed above ground in the tissues, in the living tissues of the green tissues of plants. Whereas the rest of the carbon that had been fixed that year, because 70 to 90% of your plant mass exists in your root system, would actually be fixed underground. Somewhere on average, probably between 1/2 to more than 2 tons of soil organic carbon accumulation per acre per year. So that annual carbon cycle is removing carbon dioxide, breaking it down, getting it into this soil structure. 1/3 of this root system on average dies off every year and starts to break down into organic matter. But now it's organic matter that is what? Rich in carbon. So you take the sands and the silts and the clays of the glacial till plain and slowly but surely, to the tune of 1 to 2 tons or more of SOC accumulation per year, turn it into the richest topsoil in the world. Now, have we been very good stewards of that resource? One would have to ask ourselves. Of course, the answer is absolutely not. We've managed over the course of 150 years to waste most of it. I grew up in eastern Illinois and then in southeastern Iowa, and believe me, Iowa, much of which is a much older landscape than here in the northern half or northern 2/3 of Indiana, has primarily lost all of its 18 to 24 inches of topsoil because of annual row crop tillage. One of the, without question, most ecologically and economically unsustainable forms of land use on Earth. Yellow ain't green, folks. And I came from a farm, so I'm not intending to insult any of our agricultural folks here, but the fact of the matter is it is an unsustainable form of land use in its current state. Well, okay, so we suck carbon out of the atmosphere and we build rich topsoil with 15 to 20,000 pounds of root mass per acre. Why is that relevant as it relates to water? Well, because we get about, 37 inches of precipitation per year here? Is that about what you get? That's what we get in the Chicagoland area. I think you're fairly close to us. So we get 37 inches of precipitation, more than 90% of which during rainfall events exists over a 24-hour period in less than 1 inch of rainfall. Certainly we get larger rainfall events, our 10-year and 100-year storm events between 5 and 7 inches of precipitation over a 24-hour period, okay? but 90% less than one inch of intensity of duration over that 24-hour period. So you can imagine if you had a 2 or 3 foot black organic rich topsoil blanket laced with root system across the entire geographic face of your region, what happened when it rained? Well, essentially 3 things occur when it rained here historically, none of which were surface water runoff. The only time of the year when you would have surface water runoff to any noticeable degree would be in a spring snowmelt scenario where the ground was still frozen. You have an early thaw on top. Maybe you get one of those late February, early March rainfalls on top of snow, and all of that water starts to move, if it can, although it's fairly flat. It might pond there for a while until it simply evaporated, or as the ground warmed up, it soaks back in. But most of that water simply stayed within the general region of where it's at. It might slowly work its way into a stream or a wetland system and then slowly migrate out of that. Of course, today, our snowmelt hydrology is quite drastically different than that. We have gouged and carved and piped. So when we have a snowmelt scenario, the whole system just flushes itself out almost immediately. But as a general rainfall system, in the non-frozen conditions, most of those rainfall events probably were captured in the first few inches of soil and simply evapotranspired right back into the atmosphere. And that's a very important part of the hydrological cycle that most engineers have virtually little to no training or grasp of. The ability for a living landscape system to constantly be evapotranspiring. Water goes out, water comes in. Every day if you walk out, even on your lawn, in the middle of the summer, even during a drought, your shoes are going to be wet. In a prairie, your whole leg was wet, depending on what time of year it was. So it was a very self-watering and wet system. As you get more free water moving down through those root systems, now you're influenced by the combination of topography, geology, soil structure, and you start to get lateral water flow above the water table in the vadose layer. And then eventually you get recharge of your groundwater systems as you get more free water moving down there. So the recharge of our aquifers occurred across the whole of the landscape, most effectively, of course, in the areas that were slightly higher and better drained. And then the wetlands were actually formed, in all of our aquatic systems, formed and sustained by discharge, constant, steady discharge flow. The most important thing that I can share with you today as it relates to the function of historical terrestrial and aquatic systems and the relationships between them. So water moves out, dries back up, goes into the atmosphere. It doesn't run across the surface of the ground virtually at all. Now, I wish I could say that I learned this in college. After all, I went through 4 degree programs, 2 major universities, and every one of those degree programs was related to the relationships of water and land. I didn't. I was trained in surface water hydrology and civil engineering as the conventional collect, pipe, and discharge. That's the way we're all trained, collect, pipe, and discharge. Unfortunately, the world just doesn't work very well when we misbehave in such ways. I actually learned about the way the world works hydrologically about 20 years ago from one of my today colleagues, Dr. Gerald Wilhelm, who's a botanist and ecologist. And I'll share with you, hopefully briefly, my professional epiphany, if you will. I had been working for a firm in Ann Arbor, Michigan, Johnson, Johnson & Roy, and this is back in the 80s, and we were doing a lot of wetland mitigation design because the state of Michigan had a Wetland Protection Act that had been in place since 1978, requiring that all impacts to wetlands must be mitigated, regardless of size, type, scale, or origin. So we would get out there, and of course, we thought we were fairly creative in terms of our design, and we did have a multidisciplinary team, so it was landscape architects and hydrologists and ecologists and others all working together, and we were very diligent about identifying the appropriate suite of plants that would be native to the county that we were working in, and we would come out and create little vegetated swales and little marshy areas back here, and try to buffer the parking lot discharge as best we could from the Myers or Walmart or shopping center or whatever it was that we were mitigating for. And then every year I would come back to do my annual monitoring checkup according to the DNR guidelines, which you do for a minimum of 5 years until the system is fully functional as a quote-unquote wetland. And what I would find, instead of the 50 or 75 or 100 native species that we had planted in the form of seeds, plants, tubers, and rootstocks, I would find cattails, phragmites, purple loosestrife, and reed canary grass. And almost everything that we had planted, although if we had planted in plug or tuber or rootstock form, it might grow for 1 year. It might even actually come back for 2 years. But by the end of 5 years, long since gone. Maybe a couple things, but mostly gone. And I was kind of frustrated by this because I thought I was a pretty darn good ecologist, restoration ecologist, landscape architect, and I planted those plants there and expected them to grow. Because that's what we do. Unfortunately, that's just not the way it works. So I had the good fortune in the late 80s to meet Jerry Wilhelm. At that time, he's a research taxonomist, botanist with the Morton Arboretum in Lisle, Illinois, and had been co-author, still to this day, of course, of Plants of the Chicago Region, the Botanical Bible in our part of the world, which covers parts of Wisconsin, Illinois, Indiana, and Michigan, with the late Floyd Swink. So Jerry knew virtually every native plant in that part of the country, and for that matter, virtually every native plant in any part of the country. He's a savant. At any rate, so we got together for lunch one day, and I'd met him a couple times and been out in the field with him, but we had opened a Chicago branch office, and I wanted to get together and work with this guy. He was so interesting. So we got together for lunch, and I was sharing my frustration in building all of these wetland habitats, and virtually all of the richness that we tried to get created in there turned into complete lack of biodiversity and weeds. And Jerry sat there looking at me very patiently, and didn't really say too much. And finally, when I got done chatting, he said, "Well, Jim," didn't want to hurt my feelings, "Well, Jim, those plants will never grow." I said, "What do you mean? I planted them there. I expect them to grow." "Well, you can think what you want to, but they're not going to grow there." And I said, "Why?" And he said, "You have no habitat for them." I said, "What?" "You have no habitat for them." I said, "I created the habitats for them." And he laughed. And so over the course of lunch, he explained to me the way the world works. Now, because I was a landscape architect first and a weird hydrologist engineer second, it made absolute sense. But rather than just listen to him, he said, like Missouri, don't just tell me, show me. So let's go out to Bluff Springs Fen. Now, Bluff Springs Fen is a wonderful Illinois state nature preserve about 45 miles west of the waterfront downtown Chicago, out along the Fox River near Elgin, Illinois. And so we got in the car and we wandered out to Bluff Springs Fen. And we started walking around, and here we are today. There's Jerry with his hat on, leading us in one of our annual water pilgrimages, which is what we do with friends and staff members once a year usually, to reacquaint ourselves with these basic functions and processes so that we may adapt this understanding into virtually everything that we do. So Jerry and I just that day were wandering out to Bluff Springs Fen, and it's this wonderful mosaic of hill prairies and open-grown oak timber and seeps and springs coming out of the sides of hills, obligate wetland species, and you quickly learn that wetness and dryness in a historically intact ecosystem were very undifferentiated. Not like today where the top of the hill is always dry, except for when it rains, and then all the water goes off the surface and ends up down in the bottom of the hill, and it's always wet. And then we come up with this goofy sorts of rhetoric like wetlands are for recharge. Wetlands are for recharge. Well, here's where that doesn't work so well. You see, I've got 20 ounces of water, and if a wetland, which by theory is wet 365 days a year, and I try to dump more water on top of this water is going someplace else. You see, water's non-compressible. It is impervious to itself. Not to say that wet prairies and sedge meadows with deep, rich, organic soils couldn't absorb a lot of water. They could, but once you got wet, you're wet, and the water's going someplace else. So the wetlands are not for recharge. The wetlands are actually where the discharge occurs. You see, all of that embedded water from the ground by topography and through soil and seeps and springs finally comes to the surface and manifests itself as something like I used to go around and put flags on to identify wetland boundaries, like that was relevant. So anyway, we're wandering around Bluff Springs Fen, and Jerry, of course, being the botanist that he is spewing Latin out, right and left. Well, I had been doing, restoration sort of work at that point for well over 10 years, and I knew a lot of the standard or usual suspects, if you will. But we were in a whole different realm, completely different realm of plants. I maybe had heard the genus before, but I certainly had never seen these species. And as you wander through the trails and along the hills, and then you get down into these seep zones, you see water discharging 365 days a year. Doesn't matter whether it's rained or not. Doesn't matter whether it hasn't rained. You see, because when it did rain last time, water got into the ground and is always, always working its way through the ground, where it slowly seeps out 52 to 54 degrees, because that's the annual average groundwater temperature. Slightly alkaline in water chemistry because it's soils derived of dolomitic limestones. Steady, stable, utterly stable. And you can see that as you walk along. And then we get down along the trail, and you see little holes in the ground start to open up. And here's this wonderful formation of a little woodland prairie stream, something that would have been replicated throughout this landscape around here in the upper Midwest millions upon millions of times, because this is the formation of our stream and river systems. This is how they came together with enough embedded energy, water energy in the ground to actually come to the surface and form a stream. And as we're walking down along the trail and you see wonderful things going on, I mean, there's plenty of little erosion and little sedimentation areas and so on and so forth, but this also reads like a who's who of Illinois threatened and endangered plant species. I mean, orchids and sedges that I'd never seen or heard of before. I mean, just very, very, very interesting. And you see that the hydrology is so stable and the water chemistry is so stable that there is the capacity for this system to evolve, for change to occur at a rate that plants and aquatic organisms actually adapt to. That is the inherent systems stability that was present after the retreat of the glaciers. And as we wander down through there, Jerry, is spewing off his Latin some more, and we get down to the end of Bluff Springs Fen, and you realize that it could pour. And I've been down here during and immediately after torrential rainfall events, and that little stream system never changes. Or long periods of drought, doesn't matter, never changes. The hydrology is always sustained by steady, stable base flow. Well, then we get down to the bottom of Bluff Springs Fen, and these little combined stream systems that are generated in there actually discharge out into Poplar Creek. And Poplar Creek is your standard suburban creek corridor, subject to all of the sorts of fluctuations and water quality problems that every suburban stream corridor in the Chicago metropolitan region is subjected to. And then the Poplar Creek falls into the Fox, and the Fox flows into the Illinois, and the Illinois into the Mississippi, and the Mississippi on its way down picks, of course, up the Ohio with the Wabash and the White and everything else. And then, as Jerry likes to say, then they make one big, massive bowel movement out into the Gulf of Mexico, where we kill off about 40 to 50 square miles of estuary a year with dirty, polluted, sediment-laden freshwater. Water and soil we wish we had back. But we don't, because of the way we behave with that today. So we get down to the bottom of Bluff Springs Fen, and by the way, all of that rich biodiversity, several hundred species of native who's who plants give way to, guess what? You got it, cattails, reed canary grass, phragmites, and purple loosestrife. In fact, you can draw a line somewhere around the equivalent of the 1 to 2 year 24-hour storm event in almost any wetland or stream corridor, and that's where system stability and biodiversity collapses and turns into weeds. And so you go back and you say, oh, yeah, there it is right there. And then Jerry turns around to me that day and he says, now you understand, don't you? Well, I was starting to get it. And frankly, it scared the ever-loving you-know-what out of me. And he said, here's the law, Jim. Plants grow in habitats to which they're adapted. If you change the habitat, you will most certainly change the inhabitants. I went, habitat, change the habitat. So then he said, okay, we're in southwest Cook County, Illinois. Cook County, Illinois has about 1,000 native Holocene-aged post-glacial plants. That's including all the woody and the herbaceous species and everything. And out of those 1,000 native plants, about half of them are adapted to wetland or aquatic types of systems, something that you could put a flag around and the Fish and Wildlife Service and the Army Corps of Engineers would call a hydric plant. So that's 500 native wetland species who have adapted over a long period of time to every kind of wetland and aquatic habitat, and we have quite a few different kinds within the context of Cook County, Illinois. 500 native wetland plants. And then he turned around and he said, now that you understand the context of historical patterns of groundwater-dominated hydrology and shear stability, how many of those 500 native wetland plants, in your opinion, have a long-term ancient genetic history of growing in habitats constantly influenced by inundation from dirty polluted surface water runoff every time you even get a quarter of a half inch of rainfall? And I went, not too many? And he said, that would be zero. We don't have a single native plant that has any genetic history of growing in a habitat constantly influenced by inundation from dirty polluted surface water runoff every time you get a rainfall event. And I said, wait a minute, whoa. I'm an engineer kind of guy. I've been working in wetlands for years. The two primary functions and values of wetlands are stormwater storage and water cleansing. That's what we're taught. Go to the State Department of Natural Resources, the Army Corps of Engineers, local soil and water conservation district. Why, everybody says wetlands are for stormwater storage and cleansing. That's what we're trained to do. He said, I didn't say it was smart. And all of a sudden, the clouds parted, the sunlight came down, bolt of lightning hit me up the side of the head, and I went, holy. Well, I won't say what I said. And I was mad. I was angry. So how could I have gotten through all of that school, been out here working for 15 or more years, taking water, cleaning it up a little bit, and dumping it out on top of these, because that's what wetlands are for. And then, of course, it dawned on me that the only reason that wetland becomes the repository for that waste is that where somewhere within the context of that watershed, water fell out of the sky, free, life-sustaining, and because of our behaviorship with the face of the earth, it ended up being piped, dumped, discharged right on top of that wetland as a dirty, polluted waste product. And the shame of it is, we're trained to do it. And I will tell you, that day, I said, I will never knowingly in my professional life again try to do that. I will never work on another project where I put something in a pipe and dump it out into a wetland or dump it someplace else into a stream, because it's unsustainable. Scary. Now, when I would go out and give these kinds of programs, even still today, but you can imagine 10, 12, 15 years ago, big rooms of 300-400 civil engineers, and I'm telling them that virtually everything that they've been trained to do in stormwater engineering is goofy on its face. They're like, eh? Or they look like a doe that got hit in the headlight, as the light bulb starts to go off. Oh my God, wow. Or they just don't believe it. That's really a big part of the problem. They simply just don't believe it. So the historical patterns of hydrology are not dominated by runoff, but by steady, stable groundwater hydrology and inherent water quality and chemistry from groundwater. And of course, the cross-section of most of our river corridors here is that, and the interesting thing about the plant establishment historically is that the flat till plains, because of the constant moisture moving in and out, were too wet for trees to grow. But that's where the water went in. Of course, the water went in across the whole cross-section. But right along these hillsides, along the bluffs and terrace areas where you would create this little cone of depression, the trees could get a foothold. So, too wet for trees, too wet down in the discharge zone for trees, just right. Just right. That's the historical context of the relationships between grassland and woodland systems. Now, of course, today we have so completely altered the hydrology, particularly the groundwater hydrology along our stream corridors, that we in the upper prairie states think we have forested floodplains, which is absolutely goofy on its face. It is a post-agrarian phenomenon to have the kind of stuff growing up along our river corridors in the flat, low-lying areas. That is not a historical context. Outwash. Now, if you take a look at the way we're trained today, Standard stormwater management, collecting clay just as quickly and efficiently as the law will allow, almost always through enclosed storm sewer systems where we create concentrated points of discharge. Occasionally, by law, we are required to hold that volume of water back and then inject it out through our stormwater detention basins like a lethal injection, so to speak, into our streams and rivers. And we have codes and ordinances that mandate such behavior. Why, from a landscape perspective, you would think it really isn't outdoors. It's simply exterior decoration. Why, if I get my standard street trees by code and ordinance every 50 feet, uniform, and heaven forbid that a tree might have a mind to grow a branch that's slightly different from the next one, because then, of course, you see, oh, this one's bad. You see, the warden, that's what Jerry likes to call the landscape contractor, maintenance contractors, would unceremoniously come out and chop that little branch off so that it looked ever the uniform little lollipop like the one right next to it. And then, if you have a really good landscape architect like us, well, then you plant your little groups of shrubs in 3s and 5s and 7s and 9s and 11s, and every once in a while we'll throw in a 6 or an 8 just to, kind of be creative. And then everything that isn't covered by a building or a parking lot or a roadway must be covered by the one uniform landscape element that is required, again, by code, and that would be the turf grass lawn. Of course, along the way, because as, a development sort of interest, we might have any specific fantasy that we can dream up, like, oh, gee, I want so many square feet of buildings and parking lots. I got to have a little bit of open space out there, but we'll put the turf grass lawn in there. Now, because the turf grass lawn would die if it set in water, and of course we mass grade because we have the ability through our bulldozers and our wealth and other sorts of things, and we come in and we mass grade and we take that little vestige of the historical relationship of soil between the heavens and the earth, and we unceremoniously sweep it away, put it in a big pile over on the edge of the site, run our bulldozers over it for 6, 9, or 12 months until we are virtually sure that there's nothing left living in there. And then we mass grade to a minimum of 1.5 to 1% slope for the express purpose of getting water out of the site, because the turf grass would die if it set in water. You see, Kentucky blue, the fescues that we commonly use in our turf grasses are not from North America. They are cool season Eurasian plants. I'm not anti-turf grass, I'm just anti-turf grass virtually everywhere that isn't covered by a building or a parking lot or an ag field. And so we come in and we shape and we get our minimum 1.5, 2% slope, and we create our bumps, little berms, and then in a virtual orgy of engineering inspiration, we design the yard drain for the express purpose of getting rid of water. Heaven forbid that the pipe underneath wouldn't be uniformly sealed so that just a little bit of that water could trickle its way back into the ground where it belongs. Oh, no. No, we wouldn't be good engineers if we did that. So that water must go. It goes into this little hole in the ground, works its way through the pipes and on over into the other bigger holes in the ground, the detention basins. But that isn't all that happens here. You see, we've now mass graded, compacted the underlying clay, which there's still plenty of clays in our soils, brought the 4 to 6 inches of dirt. Now this is dirt. Now this is not soil, living soil material anywhere. It's dirt. In fact, you see signs over along the development zone. We got dirt for sale. Dirt. 4 to 6 inches of dirt over the top of a highly compacted, subgraded clay where we plant our, evergreens and our other things in groups of 5s and 7s and 9s on top of the berms. Now you go back to this question of plants growing in habitats to which they adapted. How many native plants, or any other plant for that matter, in your mind have a long-term genetic history of growing in a tightly sealed, compacted hole in the ground on top of a clay bump, and heaven forbid have a little bark mulch, little thing around it? Neat and tidy and neat. None. See, the installation contractor just prays that 24-month maintenance period gets over before the thing dies, and then it's the responsibility of the building owner to have to come out and replace it and not them. Oh, neat and tidy. And heaven forbid, you see, that anything else would grow in the uniformly looking greenish thing lawn. A dandelion? Angina would set in. Oh my God, I'm a terrible human being if I have a dandelion growing in my lawn. or even a blade of grass that looks slightly different than the other blade of grass right next to it, this would be unacceptable to us from an aesthetic perspective. So in order to make sure that no dandelions grow, we put herbicides and pesticides. And you see a shallow-rooted, cool-season turf grass that's adapted to cool, moist climates, and in the middle of a good old Indiana summer, when it hasn't rained for a while, starts to go. Well, it needs resources. We often put our own fresh, potable drinking water on top of that. It is a living thing. So we've now put, of course, it doesn't have the root system like the native plants to tap the nutrients in the water. So not only do we put the water, then we put the fertilizers. So we've put all of these resources, the undissolved constituents of which head down through the pipe and off onto the way. In the meantime, once we've put all of the constituents and the resources, including often our fresh potable drinking water, on top of the turf grass lawn, it does what? It grows. This seems to annoy us, doesn't it? We can't stand for the turf grass lawn to appear as though it's grown. We must mow it and keep it nice and neat and tidy and uniform. Heaven forbid that that solar receptor might actually get up there another inch or two where it can pick up some more solar energy and build some more root and build some soil. No, 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 no. That wouldn't be acceptable. Bad behavior. We mow it, and we mow it, and we mow it. Now, in the Chicago metro region, we have 8-month mowing contracts out on all these institutional and corporate campuses where they come along and mow every week, whether it needs it or not. And, of course, every time they do, they spew 16 pounds of carbon dioxide, carbon monoxide, and other crap and corruption back into the atmosphere for every gallon of gasoline that they burn in the lawnmower. And, of course, that's fossil carbon fixed 250 million years ago in the Paleozoic era. And whether it's politically acceptable today suggests that there might be a problem with the unfettered release of fossil carbon back into the atmosphere. I would suggest to you that we ought to be a bit cautious, because it's problematic. And, of course, where does our water go? Can't go into the ground. It's gone. We wish we had it back. A few lawn care facts along the way. One of the largest crops in the United States today, the turf grass lawn. For every 3.5 horsepower engine that you burn out there, you could have driven a contemporary non-hybrid car 340 miles. Roughly 90 million lawn mowers, weed wickers, gadgets, and gizmos, and it's 5%, represent 5% of our annual air pollution across the face of North America. The EPA estimates we spill about 17 million gallons of it a year just trying to get the lawnmower filled back up, and that's actually more than the Exxon Valdez spill. We use 70 million tons of fertilizer, 67 million pounds of pesticides. That's actually 2 to 3 times more than what is used in the contemporary agriculture, which of course has plenty of its own problems. Of the 30 most commonly used lawn care pesticides, 13 are known carcinogens, 14 are linked to birth defects, 18 linked to reproductive effects, 20 may cause liver or kidney damage. The incidence of childhood leukemia in a family that routinely uses lawn chemicals is 6.5 times higher than one that doesn't. And of course, if you like your cat and your dog and you let them go out and roll around in the lawn and they eat the grass, well, then they're 4 to 5 times more likely to actually get kidney and liver cancers themselves. And of course, where does the water go? Now that it can't go back into the ground, it goes out through the pipe. But we followed the law. We have a stormwater control ordinance. We've held back that volume. We're good neighbors. It's just being sent out now, along with 40 to 60% of the nitrogen and phosphorus and other sorts of things that are also going with it, getting into our ground and surface water supplies. So you start to see it's a pattern of problems. Now you've got your detention basins, you got your dry bottom detention basin, you got your wet bottom detention basin, but when you send all of the water from throughout all of the site into the little 10 to 15% of your property that's designated for the hole in the ground, well, then that becomes a bit problematic because it's very unstable. And of course, you know, so you're armoring it this or this. Well, us engineers say, it's no problem. You know, so we get a big fluctuation out there. We'll just armor it. It's very attractive. Of course, geese like it. You see, if you naturalize the edge of these places, the geese, not quite so sure they want to go there because there might be something that wants to eat them. But when you do this, you know, hey, this is a great place for goose. And while geese lose the genetic memory of migration within one generation, they certainly haven't lost the ability to eat, reproduce, and poop. These are things which they do very effectively. And here we have, oh, this is a perfect place. I wish I worked here. I've got my nice tidy building, my nice neat lawn, groups of lollipop trees and poodle shrubs. I've got my little jogging path out along the stone-lined detention basin so that I can go out and enjoy nature during my lunchtime. Of course, that is, if the geese don't chase me away or they haven't pooped all over the sidewalk, I can. And this is wildlife. This is interfacing with nature. We like it. We must like it. We write it into every law. Of course, often because the holes in the ground have steep slopes on them, we put fences around them. I call this the water in jail syndrome. And if you have a fairly, inexpensive piece of property, well, you can get away with kind of an ugly chain link fence. But if you have a really valuable piece of property, something that you wish you could do something else with other than build the hole in the ground on 10 to 15% of your site, well, then you got to dress it up with a really nice fence. Now, this particular location, just a few blocks from our house our office in downtown Elmhurst, is a very expensive piece of property to be putting a hole in the ground with. Had they actually built the college and the Elmhurst Public Library across the street from this with green integrated infrastructure, they wouldn't have to be doing this, but of course they didn't, so there you go. So contemporary hydrology actually we've changed it 180 degrees from the historical context of stable groundwater-driven hydrology to one of very unstable surface water hydrology, where we pick up everything and dump all of it right on top of the wetlands and then come up with the kind of completely absurd rhetoric that wetlands are for recharge and they're good. The primary functions and values of wetlands and aquatic systems are stormwater storage and water cleansing. How have we become so disconnected? Well, we live here and here. Oh, this is what Jim Kunstler calls the triple NIMBY syndrome. I don't want a backyard in my backyard like my backyard. I love that one. No wonder you don't want development to occur next to you. It's going to look like yours. And of course, agriculture. We're just oblivious to the rules, but we're still governed by them, whether we're aware of them or not. And we have the money and the machinery to do anything we want, anytime, standard, whatever. But unfortunately, the physics of design comes back into play because for every action, there's a reaction. And when it comes to water, out of place, that is a very powerful reaction. And of course, what do? Even the accumulated effects of detention basins within the context of a watershed often look a lot like this when you get a nice rainfall event. What do? It's the rain's fault. It rained too much. And of course, along the way, the entire shift in the hydrology and the quality of water tears apart our infrastructure, our historical and built infrastructure. And it's not just a matter of the built environment being the problem here. It's the fact that we have completely disassociated ourselves with the historical environment, what we might call nature. You see, we have definitions of nature being pristine and unaffected by the human. Well, there is no such place, for goodness sakes. Absolutely none. And certainly not here, where every single thing that a human being needed to survive on a day in and day out basis 150 to 200 years ago here in the Muncie, Indiana area existed within walking distance of where you lived. Your apothecary, your grocery store, your clothing store, you had to understand these things, how the world around you worked. Every plant had a use. Everything was used. And all of the native plants and animals and became adapted to that kind of interaction. Not just adapted, but to rely upon, like the annual fire, the cleansing annual fire, and all of the other sorts of human interactions with the landscape. But of course, today, when we remove ourselves, in comes, well, here we are. Well, this is a riparian floodplain forest. Oh, God. Okay. The problem is plants need light. No light, no plants. No plants, no fibrous root system. No fibrous root system, no organic soil. No organic soil, no plants. Bare soil. Rainfall gets down through there, hits. If you've got any kind of topography, phew, it's gone. Where it used to go into the ground, it's gone. And what's left behind? Well, a contemporary woodland-looking thing instead of a historical woodland-looking thing, which had tremendously beautiful biodiversity, many functions and values, most of which are gone. And so, but if you start the process of restoration, if there's just that little bit of inkling of a living plant, a germ material still in that soil, the ability to respond to a human restorative effort is absolutely stunning. What can happen? Of course, here's Jerry standing next to a white oak tree that's only about 80 years old along Mississippi River Corridor in Clinton, Iowa on Mount St. Clair College campus. And you can see this is how much erosion has occurred here just probably in the last 30 years. Unbelievable. And of course, all the resources are gone. Once they're gone, they're gone. The toolkit, the repair kit, the genetic memory of your place, gone. That's why every little remnant piece of living tissue is so critical. It's all we've got here, folks. There's about 90 weeds that grow everywhere. They are the weeds that followed the people who disturbed the land around, both in the United States and other parts of the world. That's about what we've got if you disturb the 1,000 or destroy the 1,000 or more native plants that you have. And once they're gone, they're gone. And of course, there were many important functions and values in those wetland and aquatic systems, but floodwater storage and water cleansing were not one of them. That's not to suggest that you can't design aquatic types of systems for storage and for cleansing, but that's different than the phenomenon of taking a historically intact aquatic ecosystem and dumping on top of it. And of course, along the way, we live today with the hydrology of boom and bust. When it rains, massive discharge. When it doesn't rain, the whole stream systems can dry up. Would have never happened historically. And if what's left behind is this deeply incised, constantly collapsing, pulling the groundwater down with it system. And we think all of our streams are supposed to look like this. And all our wetlands are supposed to look like this, the riparian schmutz, the very few plants that actually grow in this kind of crap. And of course, as I mentioned, along the way, everything ends up going down to the Gulf of Mexico. And unfortunately, Illinois and Iowa alone contribute 35% of the hypoxia that's going on down there. Of course, Indiana's helping out plenty on their own as well. So, the CDF doctrine. Water is a precious, life-giving resource, and it should always be treated as such, and never treated as a waste product. And if you design, as I mentioned earlier, if you design with this thought in mind, we believe that it will lead you to great beauty and great function and great stability within the context of any place that you're working. So our philosophy begins with water, to promote integrated water resource management every place, because water falls every place. Every place that receives water is a place for great design and beauty. And in contrast to conventional approaches of collection and piping and discharge, it is one of receiving, cleansing, diffusing, absorbing, reutilizing, getting evapotranspiration to start up again, and not leaving ourselves in deficit, because here's where the math doesn't add up. We as a society of people cannot continue to get 36 or 37 inches of precipitation a year, send 2/3 to 3/4 of a way as a dirty, polluted waste product, and then suck more and more out of our aquifers. That's what you live off down here. You live off of aquifers, and those aquifers are drying up. Everywhere across the face of North America, our aquifer systems are drying up. I just happen to be one of the lucky people that draws off of 25% of the world's fresh drinking water every day when I turn my tap on. And that one's going down too. That would be the Great Lakes. So, think green, think decentralized, green infrastructure technologies, native landscapes, redeploy beautiful, life-sustaining landscape systems. It's life. It's not just a horticultural collection of things, and that's not bad. I'm not saying you can't do that, but find a balance. Find a balance between contemporary ornamental landscape systems and living, self-replicating landscape systems that don't need watering, fertilizers, herbicides, pesticides, will absorb all the water on there, provide multiple wildlife habitat benefits, and great beauty throughout the year. Green roof technologies. If you live in Europe today, particularly in Germany, virtually every major city mandates all new construction must be built with green roof systems. Number one reason, regional water resource management benefits. Even a shallow, lightweight, extensive green roof, which is really 3 to 4 inches of lightweight modified soil mix on top of a permeable sub-drainage layer, will effectively, in this part of the world, capture and evapotranspire anywhere between 50 to as much as 80% or more of the annual rainfall that falls on that roof. If you happen to live in a community like Chicago that has a combined storm sanitary sewer system, that means somewhere between 500 to almost 1 million gallons of water never get off of your roof that fall on it in a year and into a combined storm sanitary sewer system, like in September of 2001, when we got a 4-inch rainstorm in downtown Chicago, which within a period of 1 hour completely overwhelmed the combined storm sanitary sewer system and resulted in 2.1 billion gallons of untreated effluent being directly discharged into Lake Michigan, which closed up the entire shoreline of Lake Michigan for the rest of the season. Completely unacceptable behavior. Bioswale technologies. You know, instead of the regular convex cross-section, which is extremely hostile to anything trying to live in there, simply invert it, allow water to sheet drain in. There's enough plants that we can work with that will tolerate this kind of a sheet flow condition, help with the cleansing of that water and getting that water back into the ground. Porous and other kinds of permeable paving systems, whether it's modular systems like this or asphalts or concrete, very, very effective as part of a system. And that's why I talk today. That's why the definition of this title, or the title of this presentation, is Designing for Sustainable Systems. This is a systems approach to design. It is the complete integration of architecture, landscape architecture, civil engineering, art, ecology. No one human being, no one profession has the technical skills, breadth of training, and life experience to do this by themselves. It is inherently a multidisciplinary, collaborative process. And so you can't think about, oh, I'll stick in a couple of BMPs. I mean, Jerry just flips out when somebody mentions a BMP in our office because it drives him crazy. BMPs, that's like an into-the-pipe kind of solution. You got to get beyond the BMP. These are totally integrated systems approaches. Level spreaders, which is essentially a linear French drain that you place along, and the contour allows either a sheet drain or a concentrated point of discharge to be picked up, diffuse all of the energy, and send it along the contour and let gravity be your friend. And so if you have to have infrastructure, this is an alternative infrastructure that is highly effective. Rain gardens, you know, everybody's got a rain garden program now for good reason. They're very effective if you design them right. The ability to take a downspout, a small element of impervious cover, and simply diffuse that and allow that water to be cleansed and absorbed back into the ground where in the context of where it fell. And you can design them in so many different ways and contexts. And of course, ancient technologies like rainwater harvesting, virtually any farm that was ever built within the context of this community, any home, any farm, any city building was probably built prior to the 1920s. All of them had cisterns, and that's because you know, our forefathers and mothers realized how important it was to actually be conservative with our water. And so we're just adapting these technologies today. Here's the Chicago Center for Green Technology, designed by one of our good friends and colleagues, Doug Farr and others, or at the home scale with rain barrels. Simple little technologies. And then retention. If you have, by law, to incorporate an element of storage capacity within the context of your site, then make it the last line of defense. Never pipe something to it. Never connect an impervious outlet. Always have it be part of a system and the last part of that system, so that maybe you've got a green roof, you've got porous paving, you've got bioretention. The overflow of all those mechanisms, which often doesn't happen, might finally make its way into here, but more likely it's going to make its way into here through groundwater movement. And then you can actually create a system like this, these retention areas, that can sustain a fair amount of biodiversity and functions and real functions and values. When we first started doing these projects, of course, most projects that I'm going to share with you here in the last few minutes of the program were illegal when we started them, because the codes and ordinances wouldn't allow us to do infiltration-based design, wouldn't allow us to incorporate native landscapes. And of course, the first thing out of the city engineer or director of public works mouth was, sounds good, I don't believe it, you got to show me the data. Okay, so we worked with the US EPA and did a 2-year study in the Blackberry Creek area, which is out in the west suburban Chicago metropolitan region. It's where, you know, sprawl is heading out as fast as it can get there. And we took the existing 2020 master plan for development and all the codes and ordinances of all of the communities along the Blackberry Creek corridor, and we said, okay, here's what we're going to do, and David did all of this planning. We're going to design a series of templates, commercial, retail, residential, mixed use, all based on your existing codes and ordinances and standard development practices. And then we're going to use the same kinds of densities, and we're going to develop an alternative to that that's more of a sustainable green approach, if you will, more of a community-oriented approach, more of a kind of a combination, if you will, of traditional neighborhood planning or new urbanism combined with these kinds of infiltration-based green infrastructures. And then we're going to model them on 100-year storms, 10-year storms, 1 to 2 year storms, water quality indicators, habitat indicators. And the bottom line of all of that 2-year study was that these green technologies were extremely effective, not only in significantly reducing the amount of runoff that would get off of the site, but actually restoring groundwater hydrology to sustain the quality and the character of the historical stream systems within the watershed. So development, green development, could actually be restorative by nature. And then, of course, they said, oh, all right, it works, but it must be way too costly to do this sort of stuff. We know that while a square yard of porous modular pavement costs more than a square yard of asphalt, and we know that green roof, why, that's twice as expensive. Okay, you're thinking component, think integrated. If I have a green roof, I don't need to have a detention basin necessarily, or if I have porous pavement or the combination of all of these together, maybe I don't have any detention basin at all, maybe I don't have any conventional storm sewer infrastructure. I can design it for cost competitive or less cost. And so we actually did another 1-year study in cooperation with the EPA, the state of Illinois, the University of Illinois, and others, and proved that yes, indeed, it is actually less expensive to build green. Not only less expensive in terms of capital development costs, but less expensive to sustain through the costs of community goods and services, green versus non-green. And of course, we modeled this over the entire watershed and showed them that if they developed according to their existing 2020 comp plans, they were going to have horrendous flooding problems. And they thought, well, we've got a stormwater control ordinance. Well, they don't believe that way anymore. In fact, almost all of the communities have adopted these design guidelines as part of their development strategies now. All of that information, by the way, is available online either through the EPA or the Chicago Wilderness or through our webpage at www.cdfinc.com, and I'll show you that later. And we do a lot of what we call around the country future alternatives analysis, where we go in and do 2 or 3 day workshops with communities. And this was one just north of Atlanta along the Etowah River, where a developer was kind enough to allow us to use his property, which he had already developed. Actually, he had already developed that plan. Mixed use, if you will, big box retail and some residential apartments and so on and so forth. We took the same square footage. In fact, we increased the development square footage overall. And instead of this, came up with this, then modeled it and gave them all of the information so that it was actually less expensive to build, didn't generate runoff. They got more developable square footage out of it. It's a much more community-oriented approach, and so you can do these sorts of things over and over and over and over again. Where it really gets interesting, though, is when you start this integrated process. And I mentioned earlier, it takes, this is just a simple principle, and it's not just our principle. It is a first principle. It takes a committed sponsor, an experienced team, and a truly integrated design process to design functional, sustainable systems. How do we do it? On a variety of different types and scales. And I'm just going to go fast and furiously here because I've got about 20 minutes. This is the Mary Lee Environmental Training Center for Goshen College up in Wolf Lake, Indiana. Some of you may have visited before. Because it's a nature center or an environmental education center, they really didn't want a lot of turf grass, so almost all of the landscape is native landscape. Virtually all of the pavement areas are some type of permeable pavement system. And this is how we integrate these solutions. We have bioswales and retention rain gardens, and then we have water reuse here. We work with John Todd Research and Design out of Massachusetts. We have biological wastewater treatment systems, rainwater harvesting and reuse is zero discharge. There is no runoff that ever leaves this property. There's no waste that leaves this property. You can do everything that I'm talking about here at your home. You can have rain gardens, you can have forest pavement, you can have green homes, you can do anything that you want. This happens to be my little 1/5 acre lot with my little Cape Cod house in Elmhurst, Illinois, the combination of which leaves no water. My property, no water. No water leaves my property. Simple to do, but if I'm the only one on my block, am I going to make a difference? Just like recycling. Absolutely not. If everybody on my block did this, starting to add up. Everybody through the community did this on a site-by-site retrofit basis. Well, now that's interesting. On a watershed, you can see the cumulative effects can very, very quickly change something, something that we take for granted, like flooding and water quality degradation and habitat loss, and simply turn it on its ear. It's simple to do. This is where we need to be putting our money instead of another big deep tunnel, goofy boondoggle sort of thing that us engineers would come up with. And it's attractive. This is actually another one of our colleagues in our office, Marcus de la Fleur. He wrote a grant, got a little green roof for the front of his house, reconnected his cisterns, got his rain barrels, his entire landscape's native, his driveway is porous pavement, and so on and so forth, and no water leaves his. And he put a wonderful little brochure, which you can actually download off of our website, that talks about how to design and implement all of these kinds of green infrastructure technologies, and he has it out on a tree in the front part of the house, so that people walking up and down the sidewalk, if they're interested, can pick up a beautiful 6 or 12-page brochure and learn all about sustainable design and development. Infill projects, completely capable with this kind of integrated green design of having a healthy, green, low-energy, LEED-rated building, and at the same time completely eliminate runoff. This is the Villa Park Police Station, which is I think it's just gotten its LEED certification, hasn't it? Or, yeah, it didn't end up LEED silver. I think they ended up silver. They were anticipating gold, but the mechanical contractors stuck in the wrong heating cooling system, and I think that had something to do with dropping them down. Here, we have a green roof system. This is a 3/4 acre site, infill site. No room for detention basin. So we worked with the county, we worked with the city, and we eliminated conventional detention basins altogether, yet we're able to satisfy all of our codes and ordinances by an integrated solution of green roof. All of the pavement is a modular porous pavement system. There are integrated rain gardens and bioretention, and we could not take into consideration any infiltration that was occurring within the cross-section of that whole system, so we had to have an overflow with a standpipe. Yet, this site's never generated any runoff. And we're able to satisfy all the codes and generate a zero-discharged urban infill development. All of our storage capacity is either a combination of below ground or above ground, and we had a massive tornado and storm event in mid-August where we were doing, the next day we lost power for 4 days in our office, and we were doing a training session for Metropolitan Water Reclamation, Chicago Metropolitan Water Reclamation District, permitting civil engineers and compliance engineers the next day to train them on how to design and use these kinds of green infrastructure measures. And we came out to this site in the afternoon, and we had a massive rainfall event the night before, and there was no water standing anywhere within any of these swales, and there was no evidence of any water that had ever gotten into the overflow down into the pipe system below and gotten out into the municipal storm sewer system. So if you get a runoff event from here, build the ark and get on it, because we got problems. Josie Heights, this is a brownfield redevelopment, the city of Milwaukee's first allowed modular porous pavement streets and alleyways project. And the way we designed the cross-section, we're able to satisfy the codes and ordinances for stormwater management within our street and parkway cross-section and along our alleys in continuous rain gardens. So you can see how those pieces kind of came together. And that's water that's being absorbed, not sent someplace else. As it's getting built, you can kind of see the cross-section. You just put the pieces together so that there's always an overflow, but the overflow is an underflow, really. Restore native landscape systems. I mean, this is reconstructed de novo landscape. Obviously, as I mentioned earlier, if you have a remnant system, it's very important to maintain that. But the ability, just even native landscape restoration, can make a huge, huge difference. University Research Park, Madison, Wisconsin, a living landscape system. One of my favorite stories, and I'm running out of time, but after this had been in place for about 5 years, Jerry Wilhelm and Linda Masters, another colleague from our office, and I were up actually in this building right here working on a completely different project, but at lunchtime we decided to go out and do a little botanizing. So we were wandering around out through the prairie, and there was a woman that was walking down the sidewalk on the edge of the site, and she came over to the edge of the prairie. She wouldn't walk in, and she started screaming at us. And we were there with another landscape architecture colleague of ours who worked in Madison, and his office was in this building. And you know, at first we were so, you know, focused on what we were looking at, we didn't hear. And then we finally looked up, and she's just yelling and screaming. And she evidently she thought that we were part of the University Research Park building group, and that we were identifying where the next building was going to be built out into the prairie. And she was mad. And finally, Bruce Woods, our friend, said, ma'am, these are the people who designed and installed this prairie. And she just said, well, don't screw it up. And then she got back on her way and walked along on, you know, and we all looked at each other and went, geesh, I guess, you know, when you think about it, that was a pretty nice testimonial. The thing is, the fact that when you start to live around a living landscape, it starts to kind of get into your system. We do a lot of corporate and institutional campus design. This is one of my favorite stories, and one of our first projects that we ever worked on, the AT&T Lucent Technologies in Lisle, Illinois. I mean, this is corporate campus row, just, you know, miles of major corporate campuses with hundreds and hundreds of acres of turf grass and crap and corruption and blah, blah, blah. And so we went out because there was a mandate out of the home office in New Jersey. You see, they were having problems with their turf grass because it was dying out from goose poop. Got a fungus in there, and they said, well, you got to come up with something other than this turf grass. So we went out. This was in the spring of 1992, or actually late winter. And I did my little slide program, you know, about the benefits of native landscapes. And I didn't have a lot of imagery back then, just pictures that I had been taking myself over the course of several years. And the only project that was even underway in the entire Chicago metro region at that time was Sears Prairie Stone, which we'd been involved in. So I was talking about, well, Sears did it. Don't you want to kind of keep up the pace? And I gave them all this spiel, and they're like, yes. Oh, it sounds good. We could get some good PR. Yeah, we could get some good PR. And then they finally said, at the end of my program, they said, but we can't afford to do it this year. Oh, no, first they said, no, we just can't do it this year. I knew what they were thinking. I said, oh, really? Why can't you do it this year? Well, yeah, we can't afford to do it. I said, okay, how much money are you spending on turf grass maintenance? We do 8-month mowing contract, 3 fertilizer, herbicide, pesticide applications on this campus a year. It's about $2,500. About $2,500 an acre. I said, let us come in. We'll do a demonstration project. We'll identify the worst abused areas, and we'll integrate a native landscape system in. We'll design it, build it, and maintain it this year within your $2,500 budget. Wow, you can do that? I said, yep. Well, within 3 years, we had dug up 75 acres of turf grass. They were saving over $125,000 in annual maintenance, even within the first few years when there's more maintenance than there is when it gets outside. The only problem that they had was before long, people were coming out here picnicking on the weekends. They'd pull up along Warrenville Road, pull over to the side, or go up into AT&T's parking lots, which is a high-tech research facility, park their cars and get out with their picnic baskets. They had people wanting to get married out here. And they were like, you know, oh, well, okay, all right, but you just can't come in and use the bathroom. So don't try. Okay, so conservation development strategies, the ability to reduce infrastructure, reduce construction costs, increase life and beauty and living things, no runoff or reduced runoff, you know, all these things. You can do them in schools, churches, green churches, community halls. This is Madison Village Hall and Village Green. We can take a 100-year storm event with no water ever leaving this site, yet it's a highly energy efficient green building. This is a retrofit along the Mississippi River in Rock Island, Illinois. Just had the dedication a couple of weeks ago. This was one of the most blighted industrial sites I've ever seen. The crap that was in there, it was scary, including dozens and dozens of old piled up trucks and cars. And so when we went in to look at the site, we said, you know, rather than just demo this whole thing and get rid of all of this stuff, which is going to be pretty expensive, why don't we kind of adaptively reuse part of it? And so we took a lot of the building construction that was taken down and incorporated that into the site for our trails and parking. But this was being funded as a 319 non-point source water pollution control. So there's all of the green infrastructure, porous pavement, rain gardens, bioswales, water recirculation gardens. But we kept, these were the concepts, but we kept the foundational walls and some of the other pieces of the industry that had been there. And it's, like you can see in these images, it's kind of a cool place. Now the landscape has just all been seeded and planted this year, and it's all native, except for a couple of little pieces. And that's just starting to come in, but you can kind of, it's really fun to play with these ideas. And that's part of their Retain the Rain program. Corporate campuses, green buildings, green sites, no discharge, living landscapes. This one's just winning a Chicago Wilderness Award that'll be dedicated in 2 weeks. This is the Tell Labs headquarters campus in Naperville. Again, bioswale systems. The overflow from the bioswales go into vegetated swales. They finally make their way down to the retention areas, and then they recirculate this water. On the north side, we have level spreaders, sheet runoff, and paver runnels. They have never, in the 7 years that they've been here, generated enough rainfall to overflow this system and get out into the stormwater, the municipal stormwater system. Lots of living landscape. It's much less expensive to manage this campus than it is any of the other campuses down the row. Here's our paver runnel. The paver runnel discharges into the level spreaders. Cost $80,000 less to build this than it did the conventional, because we had to do the cost comparisons when we were in conceptual design, rather than continuous storm sewer and curb and gutter versus this kind of low infrastructure. We have very little storm sewer systems on the site. As I mentioned earlier, if you have native landscapes, actual remnant systems, it is very important to preserve and build around and then interpret these. This is actually just got a LEED Platinum rating, the new Evelyn P. Tyner Nature Center at the Glen in Glenview, Illinois. Interestingly enough, during the entire construction process last fall, the green roof system, as it was going down, had this local resident hanging out and watching them construct the green roof every day. Every single day, this hawk showed up and just hung out and watched them. I suppose it was looking for mices. This is what it looked like this spring during the dedication. Coffee Creek Center, Chesterton, Indiana. One of our real first larger community-wide events to try to build something like this. You know, again, infiltration-based infrastructure, water recirculation, overflow into level spreaders. The level spreaders then allow that water from impervious areas to be cleaned and back into the ground. And along the actual stream corridor of Coffee Creek, which had been completely overwhelmed by agricultural weeds within the first couple of years of maintenance and management, because water was now getting back into the ground and it wasn't subject to erosion and sedimentation annually like it had been from the ag runoff. Very, very, very rare and very conservative sedge meadow plants, flowers and sedges and other things were all starting to pop back up from the seed bank. And it even surprised Jerry that it could happen that quickly. Even the little restroom has its own little green roof and this little biological wastewater treatment system. I could tell you a lot more stories about Coffee Creek, some good, some not so good, and maybe we'll talk more about that as we go forward. But it really is still a place that I enjoy going out to as best I can. The ability to harvest water and integrate it into the context of anything that you do. And here, just the Peggy Nodebart Children's Nature Museum, extensive green roofs. The green roofs discharge over scuppers down a living wall. The living wall then accumulates water into these little bioretention areas. There's a small cistern and a wind and solar pump system that recirculates that water back up the living wall to irrigate the little pockets of vegetation that are growing on it. Second story has a different type of rainwater garden living roof system. And the landscape is primarily a native landscape. So here you have a nature center in the middle of Lincoln Park that essentially generates no runoff. Queen's Botanic Garden, which just the formal dedication for the new headquarters part of the administration building, which is hopefully going to be the City of New York's first LEED Platinum rated project, building project, public building project. It was just dedicated a couple of weeks ago. David was there. This is what the concept, so there's all of this rainwater harvesting and reuse. The interesting thing about when we worked on the master plan, we were working with our colleague and good friend Herbert Dreisaitl from Germany, who, if you've studied any of his work, it's just wonderful work. And I usually show some of it in my programs, but I'm already just about out of time here. But always water being a very, very visible and integrated part of the art and ecology. And everything within this site is run off of all of the water features are collected rainwater and recirculated rainwater and no discharge on site. And the interesting thing about the Botanic Garden, it is within the 2 square miles of this 38-acre site is the most ethnically diverse neighborhood in the world. More languages and more ethnic cultures come together in this small little neighborhood. And during the planning process, it was very, very interactive because all of these different community folks had a piece of the garden which was theirs, which they had their weddings at, their funerals, bar mitzvahs, et cetera, et cetera, et cetera. But the one unifying element in every culture was water. And so water became the unifying design theme. That's what actually the image of what that looked like in reality during the dedication. Here's another concept. There's what it looks like. Another concept. Here's what it looks like just coming in. And then water features, again, the thread that ties the entire garden together as it gets built out. Kresge Foundation headquarters in Troy, Michigan. This is also going for a LEED Platinum certification right now. Rainwater harvesting and reuse. The building is tucked back down in. Water is kind of one of the real driving forces behind the entire design. Green roof elements. They recirculate through these water gardens. The water gardens are built right up to the edge of the building. It's all driven from collected rainwater. We have a cistern. You can see here the cistern is in the back. Then we recirculate the water from the cisterns. Here's an indoor concept during the design phase, and this is kind of what it looked like in reality. The cistern and the parking lots are porous. The bioswales, again, it's just integration of all of these together. And I think Landscape Architecture Magazine is going to have a story on that in the next couple of months. Hospitals, a new 11-story bed tower, Advocate Lutheran General in Park Ridge, Illinois. Green roof technologies up on top. Overflow goes through scuppers. Scuppers discharge into continuous rain gardens. Rain gardens discharge into a dry well. The entrance drive is porous pavement. The entire system is all integrated piece by piece by piece together. Under construction right now. And then finally, urban environments. The ability to incorporate this kind of urban retrofits is a real opportunity for us as design professionals because there's more retrofit work really in most cases than there is new work. And one of my favorites that's going on right now, of course, if you've seen some of the work out in Portland, this is a colleague, Tom Lipton, and his staff that designed the Green Streets Initiative in Portland, where they've taken just parking lot or a drive runoff, sent that through a series of little cleansing biotopes and make it a functional art element. And that's one of the things that Herbert Dreisaitl's work is so good at. Obviously, Herbert didn't design that. We developed the green retrofit guidelines for the East River District in Detroit. The ability to take embedded energy in those buildings and then retrofit them holistically so that the buildings are healthy buildings and the site. And this was driven by water quality and water quantity management, so we were able to design all of this integrated green infrastructure right into the design guidelines. And then finally, some projects, other ones that we're doing, this is actually Racine Historic District, and we're looking at some fun stuff here. Things like harvesting water using cisterns that were there in place for the actual fire department back in the 1800s. They have still all of these vaults built right into their street infrastructure. We can take our water, put it down in there, get it to groundwater temperature, boost it up so that it gets actually a little bit warmer from using some kind of a combination of geothermal and solar sort of energy system, and then we're recirculating that. Our goal would be to recirculate that under the streets, the sidewalks, and all of the parking lots so that they never have to use any kind of snow removal, never use any kinds of salts, all from reclaimed rainwater, and then of course, full-blown green roof systems and garden roof systems. This is an arts and entertainment district. They can grow food up there for the restaurants or else for the patrons that will live in there. So it really becomes a green urban retrofit. There's a few predictions as I'll wrap up here. The United Nations believes, and I do too, that by 2025, 2 out of every 3 people in the world are going to be suffering water shortages. And that by the end of the 21st century, I believe it's going to happen well before that. Water is the new oil, and I'll close with this. Water. 3% of the water on the world is fresh water. Of that, only 1% is actually available for human consumption. As I mentioned earlier, 1/4 of it exists within the Great Lakes. That's actually 95% of the United States fresh drinking water, which is, by the way, disappearing along with the rest of it. Yet, depending upon where you live in the United States today, since the East Coast gets a little more rainfall than the West and the arid portions of the Southwest, 30 to more than 60% of potable fresh drinking water use annually goes to lawn watering. Frightening. Totally unsustainable, that's for sure. Thank you. If you have any questions, there's lots of information on our website. You can send me an email. We'll obviously be around here for the next several days, and we'll look forward to interfacing with you guys. And thank you for your patience and time.
Thank you very much, Jim, for an excellent lecture. As I indicated before the presentation, Jim and David will be visiting with individual classes for the rest of the afternoon today and also Wednesday afternoon. And then we've got some time slots where you can sign up for individual or individual team crits. The sign-up sheet is in the landscape architecture office. Time slots 11 to 12 tomorrow, 1 to 3 tomorrow, and 9 to 12 on Wednesday morning. So if you want to get some feedback on individual projects that you're doing for the Green Line, you can sign up in the landscape architecture office. Thank you, Jim.